It will probably. So I'm going to talk about our warming climate and how it's expected to change precipitation patterns and how that may affect those of us living in the watershed. And really the short answer is that we're expected to have more rain annually, more big rainstorms, and more rain in the early winter and spring. I just want to note I recently retired from the Metropolitan Area Planning Council, and some of the work that we'll look at here is from my projects there. So in the more rain annually department, as the atmosphere warms, it can hold more moisture and more ocean water is evaporated, and that leads to more rain and bigger rain and snowstorms. So this slide shows the annual rainfall history recorded at the Blue Hill Observatory in Milton, going all the way back to 1886. And the black lines show the annual rainfall, and you can see that's highly variable. And so the blue lines show a 10-year running average and a third-year running average, which sort of smooths out the trend. And I think you can see best with the third-year average in red that there's been a long-term trend up since about the 50s. So in the more big rainstorms category, these figures show that we're experiencing bigger rainstorms more often. And this shows trends since 1959, and it's basically looking at 4 different types of storms, and that's the storm that's 2 inches in a day, 3 inches in a day, 4 inches in a day, and 5 inches in a day. And in each case, the number of those that we're seeing has gone up over time since the 50s. And this actually just came out from the US climate assessment that was released this week. This is in Quincy, somebody might recognize. Also in the sort of more big rainstorms categories, one of the big issues with big rainstorms is that our stormwater infrastructure really can't keep up with it. So one of the requirements for new developments is that drainage systems need to be sized to manage what's expected to be a 24-hour storm that would happen every 10 years. And you can see here from the slide that the size of that storm has increased since 1961 and is projected to increase more. The bad news is that our state regulations are still working with the 1961 storm. So, and that one's in Milton, you may know too, in the Blue Hills. So finally, the other issue with rain is more rain in the winter. So in Massachusetts, the most recent analysis from the state climate assessment predicts that rainfall rates will continue to increase, but they also show a big difference in seasonal rainfall. The figure on the top shows that by 2070, for our location, which I circled in red, roughly our location, the expected annual increase in rainfall is between 0 and 6%, which if it were averaged out over the course of a year might not even be particularly noticeable. But looking at the summer and winter projections, you can see that in the summer, they're looking at a 0 to a 8% decline in expected rain. And then in the winter, anywhere from a 12 to a 42% increase. So that obviously changes things a lot for us. It also explains why we can expect more rain and also potentially more droughts. It's really about this seasonal difference. So MAPC has data from just the type of storm that's projected to happen more frequently as the climate warms. And that, again, is precipitation in the winter falling as rain rather than snow before vegetation has started any uptake and on frozen ground, or in the case of 2010, it was on ground that it just become saturated from recent snow melt. So some of you may remember the flooding from March 2010 at the Blue Hill Observatory. There was nearly 18 inches of rain over 3 weeks. At the time, that was actually the rainiest month on record. And there was enough rain and flooding that we had a federal disaster declaration that made people eligible to file claims for damages. So this is a map showing flood damage claims for the Estuary area from March 2010. The locations are enlarged a bit and also slightly altered to protect privacy requirements. But you can see there were a lot of claims. Boston, Quincy, and Milton all had a high number of claims relative to other communities in Eastern Mass. And that's at least partly because we had particularly heavy rainfall in this area. And you can also probably see that there are some clusters along some of the riverways. But if you look other places, really most of the claims are not associated with waterways or wetlands. They're on what appears to be dry land. In fact, for us, that was really one of the most surprising things we saw with this data, is that the vast majority of the claims were not in the areas that FEMA identifies as likely to flood on their flood maps. So as I'm saying, across our region, only 7% of claims were in the FEMA 1% chance flood zone. And that's also known as the 100-year flood zone. That's the zone where if you have a mortgage, property owners are required to get flood insurance. And you can see that Boston and Milton had hardly any claims in that zone. Quincy had more, but still less than half. One of the reasons the flood maps don't capture the flood risk is that FEMA really looks at flooding from waterways, a bit at wetlands, but they don't map the areas that have most impact in our inland areas. So they're not looking at impervious surfaces, all the pavement. They're not looking at small depressions. They're not thinking about inadequate stormwater infrastructure, high groundwater, potentially historic wetlands. So it's the maps don't capture it. It's not that they're wrong. It's in the sense that that's not what they look at. So, sorry, I'll stick with this for a minute. One of the things that we found was at MAPC, we interviewed residents from the city of Woburn about their flooding experience, and we learned that most of them had no idea their homes were at risk for flooding until they were actually underwater. So almost all of them experienced flooding from groundwater seeping into their basements. They also reported that the flood experience caused them health risks from mold, tremendous financial problems, and really very significant stress. And I think their experiences actually were common across our region, and that we're going to have a lot of work to do to alert people to the risk of flooding that's outside of flood zones, and also to help people prepare their properties to be less vulnerable to flood damage in the basements in particular. And then I just wanted to say at least a bit about impacts on natural resources. I've talked a lot about people and infrastructure. So low groundwater levels due to drought or water withdrawals or development patterns can be damaging to the health of our river and wetlands. And I think probably NEPA talks a lot about that in the upper watershed. But high groundwater levels can also be problematic. If they come into contact with pollutants in the soils, they can mobilize those into our wetlands and waterways. And then, of course, during big rainfall events, stormwater washes pollutants, washes sand, washes other kinds of things into the water and wetlands. Combined sewer overflows can also be a problem for causing water pollution. And rains can scour our stream beds and banks. And then the final thing I wanted to notice is that we talked a bit about the estuary impacts, is that increasing rainwaters can have an impact on the estuary in terms of changing actually the chemistry of the ecosystems. In other words, making it less salty, which can have an impact on what can survive there, and also potentially on increasing invasive species. Okay, and I think that's it.
Thank you.